Hi, I'm Jawad. I'm going to be covering the discrete uniform law and conditional probability. Let's hold our horses here. What even is probability? Probability is a way of expressing the likelihood of some event happening. In probability, there's this thing called a sample space, and the funny little Greek letter you see is omega, which also denotes sample space. We're not going to delve into the specifics of sample spaces, but basically a sample space is a set of all possible outcomes of an experiment. Think of it as a complete list of everything that could happen. Let's say that you go to some event and you meet a friend's uncle and he's like, hey, let's roll this die and see what we get. If we're asked what the sample space of this experiment is, what would we say? Well, we'd have to consider all the possible outcomes of this experiment. We could roll a 1, that's one outcome. We could roll a 2, that's another outcome. We could roll a 3, a 4, a 5, and a 6. Those are all the possible outcomes of rolling a fair 6-sided die. And so that's our sample space. Now let's jump into the discrete uniform law, the actual meat of our video. We can use the discrete uniform law when a sample space is both discrete and uniform. For a sample space to be discrete, it has to have a finite number or countable number of possible outcomes. And for a sample space to be uniform, all the outcomes have to be equally likely. The discrete uniform law tells us that the probability of an event A is equal to the number of elements of A over the total number of sample points, or the cardinality of A over the cardinality of the sample space. Here in our die example, our sample space is both discrete and uniform. It's discrete since we have only 6 possible outcomes, and it's uniform since the likelihood of rolling a 1, 2, 3, and so on is the same. There are 6 outcomes, and the likelihood of one of those outcomes happening is 1 over 6. Let's say we have an event B. Event B is the event in which the die lands on an even number. We're asked for our experiment, we have to find what the probability of event B is. Here we can actually use the discrete uniform law. Probability of B is going to equal the cardinality of B divided by the cardinality of our sample space. Let's start with the cardinality of our sample space since that's easier. Cardinality is just a fancy word for the number of elements in a given set. The number of elements in our sample space, if we use our advanced counting techniques, it's 1, 2, 3, 4, 5, 6. There's 6 elements in our sample space, so the cardinality of our sample space is 6. Finding the cardinality of B is going to be a bit more difficult. We actually have to form the set B. B is the event in which the die lands on an even number, and the die is only going to land on an even number when it's 2, 4, or 6. So B actually only comprises of 2, 4, and 6. That's our set B. And the cardinality of B, if we use our counting again, we can see that the cardinality of B is 3. And if we simplify, we see that the probability of B, probability of rolling an even number, is 1/2. Now that we've taken a look at discrete uniform law, let's take a look at conditional probability. This concept deals with the probability of an event occurring given that another event already happened. The formula for conditional probability is here. The probability of A given B, this little line means given, is equal to the probability of A and B over the probability of B. Let's jump into this example real quick. Your friend's uncle rolls the die and tells you that it landed on an even number, and he doesn't lie, and he wants you to guess what number it landed on. You guess 4. What's the probability of your guess being correct? This big old thing is basically just asking you what's the probability of the die landing on 4 given that it landed on an even number. That's basically what it's asking you. And so we can call event A the landing on 4, and we know that event B is just going to be us landing on an even number. So we're finding probability of A given B. The formula we can use is up here. Probability of B, we already know to be 1/2. We have to find the probability of A and B. And for this, we're going to use the discrete uniform law. So what's the cardinality of A and B divided by the cardinality of a sample space? That's our probability of A and B. Well, to find what A and B is, let's take a look at what event B is. Event B is the event in which we land on an even number, and we land on an even number when we roll 2, 4, or a 6. Event A is literally just landing on a 4, and so it's just that. And so the overlap is only going to have that. So our sample space, our set A and B is just 4. And the cardinality of that set is 1. And if you remember, cardinality of a sample space is 6. Now let's plop in all our numbers into the actual formula. The probability of A and B we found to be 1 over 6. And the probability of B we know is 1/2. And if you simplify this, you're going to get 1/3. And that's conditional probability. And in the next video, Jason's going to cover the basic counting principle. So be on the lookout for that.